Hi friends, in this video I would like to discuss about salt hydrolysis. So first, hydrolysis means reaction with the water. Hydrolysis means reaction with the water. So hydrolysis means reaction with the water. So now salt hydrolysis means the reaction in which the reaction in which the reaction in which cation or anion or both of salt. So the reaction in which cation or anion or both so react with the water react with water to form H plus or OH minus or both is known as salt hydrolysis. Is known as salt hydrolysis. So salt hydrolysis means simply hydrolysis means reaction with water. So the reaction in which cation or anion or both of salt react with water to form H plus OH minus or both is known as salt hydrolysis. So now here all types of cations and all types of anions does not react with water, means they won't participate in hydrolysis. So what kind of cations can undergoes hydrolysis? So the cations which are stronger or which acts as strong acid, they can only undergoes hydrolysis. Let us see some examples. HCl, when you dissolve in water, so that one can produce H plus ion and the next one Cl minus ion. So now you see HCl is a strong acid. HCl is a strong acid. Now you see Cl minus is a conjugate base of HCl. So now the conjugate base of strong acid always acts as a weak base. Now here Cl minus is a weak base. So this is not a strong base. If it is strong base, this one undergoes hydrolysis, means this one can react with water. So now Cl minus is a weak base, so this one won't undergoes hydrolysis. So Cl minus, when you treat with water here, so this one does not take part in hydrolysis. And the next one I am taking acetic acid, CH3COOH. So now when you dissolve this one in water, this one can produce H plus ion and the next one CH3COO minus. So now we know that so acetic acid is a weak acid. So now this anion is conjugative base. So the conjugative base of the weak acid always acts as a strong base. Always acts as a strong base. The conjugative base of strong acid is weak base and the conjugative base of the weak acid is a strong base. So now this anion undergoes hydrolysis. This one can participate in hydrolysis. Then CH3COO minus, this is acetate. When you treat with water, this one undergoes hydrolysis and forms CH3COOH. So whatever this one participate in hydrolysis. So this is a stronger one. This is strong strong anion. So this one undergoes hydrolysis. So this is a weak anion or this is a weak base and this one won't participate in hydrolysis. And this one is a stronger one, strong base or strong anion. This one can undergoes hydrolysis. Next one, let me take two more examples. NaOH. NaOH, when you dissolve in water, so this one can produce Na plus and the next one OH minus ions. So now you know that NaOH is a strong base. NaOH is a strong base. Next one, what about Na plus? Na plus is the conjugative acid of the NaOH. Okay, so now the conjugative acid of strong base always acts as a weak acid. So now here Na plus, when you treat with the water, so this one does not participate in hydrolysis. In the next example, NH3 or NH4OH. NH4OH, when you dissolve in water, so this one can produce NH4OH. When you dissolve in water, this one can produce NH4 plus, and next one OH minus. Now you know that, so this one is a weak base. NH4OH is a weak base, and NH4 plus is a conjugative acid. So the conjugative acid of a weak base acts as a strong acid. Strong acid. Now once you see here, this is strong acid, and this one can produce conjugative base. So the conjugative base of strong acid is weak base. Next one, this is weak acid. This one can produce conjugative base, that is acetate. So acetate is conjugative base of weak acid. So then this one is strong base. So the conjugative base of a weak acid is strong in basic nature. Next one, NaOH is strong base. So now this one can produce conjugative acid. So the conjugative acid of a strong base acts as weak acid. The conjugative acid of a weak base acts as a strong acid. So now here this NH4 plus, when you treat with water, this one undergoes hydrolysis. So this one undergoes hydrolysis. Now this is strong ion, and this one also strong ion. That's why these two can participate in hydrolysis. Cl minus and the next one Na plus. So they are weak ions, so they won't participate in hydrolysis. Right. So next one, hydrolysis we can classify into two types. So hydrolysis we can classify into two types. First one is cationic hydrolysis. Cationic hydrolysis, and second one is anionic hydrolysis. Anionic hydrolysis. So in hydrolysis, if cation participates, that is known as cationic hydrolysis. Otherwise, if anion participating in hydrolysis, that is anionic hydrolysis. For example, I am taking B plus is one cation. This one I am treating with the water. So when you treat this one with water, now here you know that H2O contains two parts, H plus and next one OH minus. So B plus combined with the OH minus and can produce BOH, and here you can get H plus, right? So when cation reacting with water, the resulting solution contains H plus ions, then you can say that this solution is acidic in nature, and for this one pH is less than 7. pH is less than 7. One example, we can take one strong cation, or you may take ammonium cation. So this one is strong acid, that one can undergoes hydrolysis. NH4 plus, when you treat with the H2O, so this one can produce. So in this one we have two parts, H plus and next one OH minus. So this NH4 plus can combine with OH minus and produce NH4 OH, and you can get H plus. Now the resulting solution contains more number of H plus ions, and for this one pH will be less than 7. pH will be less than 7. So this is cationic hydrolysis. And the next one, anionic hydrolysis. So anionic hydrolysis means, so in the hydrolysis, anion reacts with water. So I am taking one hypothetical anion A minus. When you treat this one with water, so you can get here, so H2O contains H plus and OH minus, and A minus can combine with H plus and forms AH, and the next one OH minus you can get here. So anion, when you treat with water, we are getting OH minus ions. So this is basic in nature. So this solution is basic in nature, and here pH is greater than 7. One example we will take. So that is, you can take a strong base, that is acetate. So acetate ion, when you treat with water, so here you can get CH3COOH. So here this one contains H plus and the next one OH minus. H plus can combine with the acetate ion and forms acetic acid, and next we have OH minus ion. So in this solution OH minus ions present. So this is basic in nature, and for this one pH is greater than 7. Thank you.